I would like to introduce Professor Noshin Omar, that he's an associate professor of Mondragon University and also the CEO of and founder of Avesta Battery and Energy Engineering. To achieve the climate neutral society by 2050, which are the main actions to be taken to get the lowest possible CO2 footprint for batteries?
From my perspective is, as I mentioned before, green manufacturing of batteries and typically taking the energy from the renewables, one thing. Secondly is a green recycling of batteries, because for recycling you need quite enormous amount of energy to recycle that. And that are definitely two key aspects that should to be taken into consideration.
We know that the lithium-ion battery market is exponentially growing, as you mentioned, and the demand of the electric vehicles is also increasing. And we are demanding the cost reduction, and we expect that. But related to that, how could we reduce the lithium-ion battery production cost while maximizing cell performance? I mean, regarding the battery manufacturing.
Now, in one of the slides, I mentioned clearly that indeed the demand on batteries will increase. And typically when the demand is increasing and the availability is low, the prices are increasing. However, during the coming years, there are two parameters which are going to play very important. The mass production is popping up. We have more and more gigafactories in the world. But also we are increasing the energy density in the same volume. Because of me, the increase of the energy density is much going faster than the increase of the prices which are related to the materials, and which this trend actually is resulting to dropping of the prices of the batteries.
Okay, thank you. And related to new trends in technologies, you mentioned, for example, solid-state batteries, which are claimed to be safer and long-lasting with higher performance in energy density. In your perspective, which are the most promising technologies, and how could we manufacture those new technologies and recycle? Is there any changes in recycling process, for example, and manufacturing?
Now, the manufacturability of solid state is completely different from lithium-ion batteries. Extremely different. Even we and the company, we are facing a lot of problems. Regarding recyclability, recyclability is also different because the types of materials which are used also are different. But this is still a topic which is under discussion and under development and research. At this moment, no one has actually a clear view how the future of manufacturing of solid state and recycling will look like. Sodium-ion batteries, we definitely see potential, but more a potential for stationary market because the energy density is low, and it creates a lot of potential for stationary market where the cost is a dominant factor.
Which will be the business model for the next years in this energy storage field?
One of the business model which I see definitely going to happen is every vehicle per definition is standing 95% of the time. Take your car, it's standing or parked for 95% of the time, and when it will be electric, it is already energy which is integrating. So we are actually speaking about that moment, mobility of batteries, such terms. One of the business models that I see is the concept of vehicle to grid, vehicle to home, vehicle to building, vehicle to grid, or vehicle to X in general, and to benefit from there as well as much possible, and growing market which we see from there, because penalties which are associated to grid imbalance are quite very high.
Related to the BMS and the battery pack design strategies, okay, current students will address or will be the new generations to promote sustainable energies and renewable energies. Can you give a guideline briefly to build the smart battery packs and which are the main design aspects that they need to be addressed?
The development that we are seeing are more related to a concept like cell-to-pack, where there are no modules anymore. And the technologies and the developments where we see happening is by integrating smart functionalities like wireless sensing technologies and cloud connected solutions, how I should say, predictive maintenance solutions integrated there, with also a lot of cybersecurity functionalities. Last but not least, also what is very key in that regard is the fact to detect any specific failures mechanisms in the batteries in a fast way. When it will be popped up, I think that should be available something before 2025.
And regarding the cloud computing that you mentioned, how do you think that the new cloud computing capabilities and interconnectivity will affect the battery state estimation and fleet management?
That will change the impact on the BMS definitely, from the processing time and the effort that will be needed for processing. But you have to see the cloud as just a platform where data come in and data come out. And that will not affect too much the BMS. What it will affect actually is the reliability of data, how the data fast can come in, how reliable the data will be, and how fast they can be processed. And then the impact on the cybersecurity should not be underestimated. The date that the moment that all car manufacturers will make this cloud open for another users, it will be the first step in the right direction for second life applications. Because all the parameters which are related to state of health and the characteristics of the battery will be at that moment stored in the cloud. But take into account, this cloud is not only interesting from that perspective. Cloud is also interesting for the maintenance point of view, where you can do predictive maintenance, plan the maintenance, everything from the cloud. If you see from the cloud, everything, some strange data are coming up from the battery, which are not normal, you can already from there take the battery or the vehicle out of the service and plan the maintenance accordingly. And that is something very essential for fleet management.
And going more in deep, for example, in the field of state estimators, we were mentioning the state of health and some impedance measurements on that. Regarding the other state estimators, the state of function, state of safety, or in general the estimators, do you think, what do you think that will be the future trend? And if you see electrochemical models, how do you see the entry on the market of a state estimator based on electrochemical models?
Now, first of all, state of health, I said state of health estimation for second life. I just gave my view, what could be the potential solution. However, when it comes to state of charge, state of function, state of power, state of energy, state of safety, there are different another types of technique that could be applied. And the most one which can be easily implemented is a Kalman filtering. Kalman filtering, where you need a lot of training, of course, and fuzzy logic and neural networking, where you need also a lot of training for that. But that are the most reliable functionality that could be implemented. However, can electrochemical modeling be integrated in a BMS platform for state of estimations? I don't believe that. Why? Because electrochemical models are from nature very heavy. and they are only possible and good for offline techniques, and definitely not in a vehicle where everything is online. If such models, of course, will be reduced in order, from the complexity point of view, it could have a potential, but you have to take into account the amount of data that are already processed in any BMS is already so much. And if we include a higher level of complexity, that's going to make the processing effort quite a unit very expensive.
Finally, how do you see Europe in the race for the market share of batteries in competition to other continents, for example, for Asia or America?
Frankly speaking, what I see right now in hectical situation in Europe, by expanding in a fast way the battery production capacity. However, I'm little afraid that in 5 years, many of those companies that are launching now batteries factories will not survive due to lack of a very clear strategy. Nevertheless, Europe needs a lot of capacity and to fulfill our needs, but still it will be very hard to compete with China due to 2 reasons: the high incentives which are available in China. Secondly, availability of raw materials that they have. As I mentioned in one of the figures, we are very poor in raw materials. We don't have lithium, we don't have cobalt, we don't have nickel. Let's say, summarize, we don't have anything. So it's a full supply chain in Europe, which is under high pressure. We will get competition not only from China, we'll get easily competition from everywhere in the world.